Welcome to my channel, Code with Fernando. Today we are going to see Phase 3 Module 2, Hot versus Cold Publisher. Okay, this is going to be a little bit of introduction. And why does it matter? Okay, in reactive programming, when and to whom data is emitted is as important as what is emitted. Okay, this is a core idea. It's really important to pay attention to this. Okay, once we understand this, reactive programming is going to be so much easier to understand. First of all, cold publisher starts producing data per subscriber. Each subscriber gets its own full data sequence. So I think this is the most important part of in here. Each subscriber gets its own full data sequence. Okay, then we continue with hot publisher. Hot publisher produces data continuously, regardless of subscribers. Late subscribers may miss past data. Okay, late subscribers may miss past data. Okay, so the data will continue flowing continuously. What are we going to cover in here? What cold and hot publishers are, how subscription timing changes behavior, converting cold to hot using operators such as publish, connect, share, and catch. Also, choosing the right type for the job. Also, avoiding pitfalls, late subscribers, repeated side effects. Let's continue with cold publisher. Okay, cold publisher. Definition. A cold publisher emits data fresh for each subscriber. Okay, a cold publisher emits data fresh for each subscriber. It means every subscription re-executes the source, so each subscriber sees the sequence from the start, even if they subscribe at different times. Okay, it doesn't matter if the subscriber comes late or if it's present from the beginning. It does not matter in here. So each subscriber will get the same sequence of data. Behavior emits data per subscription. Subscribers are independent, no data sharing. Perfect for request response, such as database calls or pure functions. Use cases, when to use cold publishers. When fetching a book from a database, mono from a book, HTTP call to a remote API, a static list from memory, any on-demand reproducible source. So what is the key takeaway that you must understand in here? Every subscriber gets the entire stream from the start. Every subscriber gets the entire stream from the start. This is ideal for isolated, consistent, and repeatable results. Okay, let's continue with our code demonstration with a cold publisher example. Okay, I've created a class called cold publisher example, and here we are going to demonstrate something really interesting. First of all, I need to create a counter. Okay, counter to track how many times the database will be called. For that, let's use atomic integer. Let's call this counter. New atomic integer set to 0. Okay. After that, we are going to see these two messages: call publisher demo database book fetch. Okay. Let's continue with watch how each subscriber triggers its own database call. Okay, let's begin. First of all, we need to create our call mono. Okay, this means each subscription will execute the supplier. So how do we do that? Simple. I think I need to create a record in here. Let's create a record. Let's call it book. Okay, book. Okay, this book will have a title. We have a author. Then local date time. Fetch add. Okay, simple as that. So once we have our book record, okay, let's create our supplier here. Let's call this book mono. Okay, then mono from supplier. Okay, great. In here, what are we going to do? I just want to say something here because it's really important to understand this code will run every time someone subscribe. Okay, so let's call call number. Yeah, sure. Call number. Let's take the counter, increment and get. Yes, sure. Now let me print something here. Let's print database call signal. So I'm printing this because I want you to see how many times will this code be executed. So that's why we need this atomic integer call number fresh execution started. Great. I'm sorry. Okay, in here, what do we do? Let's simulate something here. Simulate database query delay. Simple as that. Okay, so let's have a try catch in here. And inside our thread, inside our try catch, first of all, I need to write here interval exception. Okay, in here, thread sleep. What about 300? I think it's okay. 300. Okay, what's going on here? Develop exception. Interval exception. Okay, now in here, let's thread govern thread. So interrupt. Great. In here, let's throw new runtime exception. And in here, let's pass the exception. Okay, great. So we have our mono in here. So finally, let's create what are we going to return. Okay, this is going to be the proof that each subscriber will get something new. Okay, so let's create our book in here. Our book. So new book. Book. Okay, great. Let's call this book Reactive Programming. Reactive Programming volume. Okay, as simple as that. Then let's call number. Let's call this one. Okay, this one. Then comma author. Great. Again, call number. Comma local datetime now. Okay, so let's bring something here. Database return. Okay, so what is this database going to return? Okay, this is something interesting. Let's take the book. Let's print the title. Okay, title, and also a number of times that this will be executed. Was executed actually. So let's call times. Let's call number. Okay. Great. So this is going to be so much clearer now. Now let's return the book. Great. Okay. Now what do we need? Okay. We need to subscribe. Otherwise, nothing will happen. We know that already. So let me print something here. So let's make a space in here. And what about subscriber? Subscriber 1, subscribing. Okay, great. Okay, here let's call mono, call book mono. Okay, call book mono. Subscribe book. Subscriber 1 got and print book title. Okay, great. let's simulate sleep now. 100. It's okay. Okay, what are we doing here? Oh, exception. Sure. Let's add the exception. This one. Okay. Now let's add 2 more subscribers. Yes, 2 more. Okay. What about subscriber number 2? Subscriber number 2. So this guy also, he got the book. Okay. Subscriber number 3. Okay. This guy also, subscriber number 3, will receive the same book title. Oh, okay. So finally, so we can have a better idea what are we doing here, let me print this result. 3 subscribers equal to database counter get. Okay. Database. Okay, which means how many times was the actually database being called. Okay. Finally, let's print this. I know this is a lot, but it's important to have some message so you can have a better idea. So we can have a better idea actually. Otherwise, it would be kind of difficult to, I'm gonna get confused. Each subscriber triggers for execution. Great. This is great. So, I think I need to understand something. Okay, this is great. Okay, so let's see. Before I run the application, I just want to explain what's going on here under the hood and what are we going to see also. Okay, what are we demonstrating here? This is a database call. Okay, this is a database call which is going to fetch books. Okay, so what are the key components in here? We have our atomic integer, this one. Initial value is set into 0. Okay, then we have our mono from supplier, which is this one. Okay, our mono from supplier, this one creates the call publisher, okay, using supplier. Okay, this one is responsible for creating the supplier. Okay, then we have a database simulation. So this one, the database simulation. Okay, there is a small delay. Okay, we want that. Finally, we have 3 subscribers. These 3 subscribers. Okay, we have 3 subscribers. Each subscriber, okay, all of them subscribe to the same mono. Which mono? This mono. Okay, so what is the result? What are we going to see in here? So you might be asking, what makes this call? Because we are going to see that every time someone subscribes, it triggers the supplier again. Okay, so independent data, we have not see that the data is sharing among subscribers. Okay, so the proof will be that 3 subscribers will get 3 database calls. Okay, how are we going to see this? Through the counter. Okay, so now they have already explained this in detail. Let me see this in action. So let's see that the counter goes 1, 2, 3. Okay. 1, yes. 2, 3. 3 database calls. How many subscribers do we have? 3. Okay, this is proof it's called. Each subscriber triggers first execution. We know that. Okay, let's continue with hot publisher. So hot publisher, this one emits data whether or not anyone's listening. Okay, so if you subscribe late, there is a good chance that you are going to miss values that have already been emitted. Well, let's see the behavior of hot publisher. Emission happens independent of subscribers. Late subscriber means every items. Okay, data is shared across all subscribers. This is really interesting. The data will be shared across all the subscribers. This is quite common in push-based or live systems. Use cases like live sensor readings, UI click events, WebSocket message streams, stock ticker telemetry dashboard. So the important thing to remember in here is to hot publisher, don't wait for subscriber. Miss the moment, miss the data. Okay, perfect for real-time events where replay isn't required. So what are we seeing these methods, publish and connect? Because I'm gonna create some examples and we need to understand this method before doing that. So let's begin with publish. It creates a connectable flags, okay? Transforms any flags into a dormant hot publisher. No data emission until connect is called. Allows subscribers to join before activation. Returns connectable flags instead of flags. Then we are going to use connect. Activates the connectable flags, okay? Stops the actual data emission. All current subscribers immediately receive data. Late subscribers will miss previously emitted data. Returns disposable for cleanup control. So what are the key benefits of using this hot publisher? Manual control. You decide when to start. Coordination. Add multiple subscribers before starting. Synchronization. All initial subscribers start together. Resource management. Start, stop, data source on demand. What are some use cases? For example, coordinated broadcasts to multiple clients. Expensive operations shared among subscribers. When timing of data starts matters. Resolves intense streams that need control activation. Okay, let's begin with our code demonstration. This one is going to be for the hot publisher. Okay, I've created a class called hot publisher example. Also another recording here, which is called stock price. Okay, which has a string in and a local time. Okay, to save some time. So now for this one, we are going to use publish and connect. Okay, so let me create a static method, and let's call this publish connect sample. Okay, simple as that. Let me print something here so we have a better idea what are we doing. Okay, let's call this example one using publish. Okay, that connect. That's it. Now I need to create atomic integer. Oh, let's call this stock price counter. Stock price counter. New atomic integer, and let's set the initial value to what about 100? Okay, good. Now, let's create our connectable flags. Let's create a connectable flags. Okay, connectable flags. We know that it's hot, but not started yet. Okay, there's an error in here. Now, great. So now let's create connectable flags of type stock price. Okay, let's call this stock feed. Now flux interval. Let's give a duration of 100 milliseconds. Duration 100. Okay, now what are we going to do? Okay, we are going to map this. Let's call this tick. Okay. Oh, what's going on here? Okay, this is great. Now what do we do? Let me get the price. So current price. Okay, let's get the stock price counter and accumulate. No, add and get. Yes, this one. Sure. Now Let's get a random number of that. Let's use the math library, random, okay? Multiply by 10, and you're going to minus 5, okay? Oh, what are we getting here? Double, okay. We are going to cast this. Okay, we have our random number. Now let's get our price. Price will be new stock price. Okay, so let's give a symbol, AAPL. Now what do we need? The current price. Okay, finally the time, local daytime. Now, what do we get in here? No, local time. Local. Okay, now it's working. Let me print something here, so we have a better idea what are we doing. AAPL, okay, equal to dollar. Okay, now let's print the price. Of course, price. And what about add? I know this is kind of confusing at the beginning, but later when we check this example, we will have we'll know what are we, why I am doing this. Price timestamp. Okay, format. Okay, price timestamp. Okay, and here what do we have? Let's pass this time format. Okay, great. So now we need to return the price. Great. Let's close this. What are we getting here? Flux. Okay, good. Now publish. Okay. Okay, what is publish doing here? This one is responsible to create a connectable flags. This one is hot, but dormant. Great. Then what are we going to do? We need to add a subscriber before connecting, okay? So let me add some comment here. Subscriber before connecting. Okay, in here, what do we do? Let's take the stock feed. Subscribe, yes. Price. Here, subscriber. Subscriber. Okay, subscriber number 1. It will get subscriber 1. Price. Price. As simple as that. So let's create another one. The other one will be subscriber 2. Okay. Now let's make a delay in here. That's why we are going to use thread sleep 100. Okay. What do we get in here? Sleep. Okay. Let's add the exception. Great. Now we need to use connect. Okay. Remember that. Now let me add some comment. So this one will be responsible for start for the actual data flow. So how do we do that? Okay, let's create stock feed connect. That's it. Now another thread sleep for about like this 100,015. Okay. Now we have 2 subscribers. So we need another subscribers to arrive late. So for this one, let me do something. Okay, what about if we print something here so we have a better idea what are we doing? Okay, why do we? Okay, and in here, this one will be late subscriber. Late subscriber joins. Okay, joins a running feed. Okay, so what? How do we do this? Okay, let me copy this one because it's going to be kind of similar. Kind of similar. Okay, let's call this late subscriber. Late subscriber. What about in here? Let delete this. We're going to delete this. And after that, this is going to this one is going to will not get all the data because we know missed earlier data. Okay, now another thread sleep. What about? Okay, great. Now finally this is the end of the publisher. End of publisher. Okay, so we are going to print this. Okay, not yet. Now we need to create our main method, which is already created in here. Okay, let me do this. Okay, now let me print something here. Hot publisher. This is our hot publisher demo. Okay, we know that. Now let's call this method publisher connect sample. Okay, another exception. Sure, why not? Okay, and let's sleep. And what about 1000? Okay, let me run this application. Okay, now before running the application, I want to give some context so we have a better idea because it's a lot of code and actually it's kind of confusing at the beginning. Later, you're going to have a better understanding what I'm talking about. So let's think of this like a live concert, okay? This live concert hasn't started yet, okay? So which means we can sell tickets. We can sell tickets. Selling tickets will be equal to adding subscribers. But the band won't play until we give the signal. Okay, the band is waiting for our signal in order to play. Okay, that's it. So what are some important key points that I want to share with you guys in here? First of all, we are going to create the connectable flux. This one, okay, connectable flux. That's why we call we use the publish operator. Okay, publish operator is the responsible for creating a dormant hot publisher. Okay, hot publisher, but dormant. Okay, it's like setting up all the equipment, but not turning it on yet. Okay, we are just setting up the equipment. Okay, pay attention to no data is flowing. Okay, the data is still. Okay, no data is flowing. Okay, then we have adding subscribers first. I mean these two subscribers. Okay, we can add subscribers before starting. It's like saying, for example, the people who are at a concert, hey people, please take a seat. Okay, something like that. Or which means both subscriber 1, subscriber 2 are ready and waiting. Okay, the feed okay, still shows no data yet. There's no data yet. So when and what is the actual moment? Let's say the magic. Okay, this is the magic. Connect. So now we call connect. This is like telling the band to start playing. Hey guys, now you should start playing. Now you should start playing the music. Okay. Immediately, when this happens, when we use connect, okay, immediately both subscribers start receiving the data. Okay. They both get the same data because they are sharing subscriber one and subscriber two, they are sharing one live stream. Okay, so after that, what's going on? There is another subscriber, but this one comes very late. That's what I'm calling the subscriber, late subscriber. Okay, so late subscriber is kind of different because this guy, the late subscriber, joins the concert, but the concert is already running. Okay, the concert has already begun. Okay, so they miss all the early songs. So this guy, the late subscriber, have already missed some songs. Okay, this is a perfect. I'm not gonna say perfect, but this is a quite good example of a hot behavior. Okay, so let me run the application in here. So what is the difference? Why should we use publish and connect? Okay, I think we have the moment we control that. We control exactly when the data should start. So this is perfect for the scenarios, for example, where we want to coordinate multiple subscribers before the beginning. Okay, great. Let's see subscriber one. Mm-hmm. Hot publisher. Okay, great. But this is not a concert, of course. I was giving the example of a concert. So let's see this: $106, $108. What about subscriber three? Let me see this. Not subscriber three, late subscriber. Oh, okay, another. Yes, this guy miss every data. Yeah, sure. Late subscriber.